Hello, I welcome you all to this exciting video. Today we'll be looking at bases, and in our previous videos we have discussed acids, everything that you need to know about an acid. So if you're watching this video for the first time, please make sure that you have watched the previous videos under the topic acids. Okay, so bases also fall under the topic generally that we call acids, bases, and salts, and these are discussed together because they're somehow linked to each other. Okay, so bases, we defined bases as anything that will react with an acid and produce a salt and water only. Okay, so a base is a substance that reacts with an acid to form a salt and water only. So bases are hydroxides or oxides. Okay, bases are basically hydroxides or what? Oxides. Okay, so hydroxide, we've been discussing about this even under the topic acids. This is the hydroxide, and oxides are merely these. Okay, so you find that when you look at these two, a base will either contain the OH called the hydroxide group or the oxide group, and these two are what we call as the radicals. Okay, we call these as the radicals. So bases contain either the hydroxide radical or the oxide radical. Okay, and you were said when these two radicals combine with a metal, that is what actually makes what we call bases. So they are actually metal hydroxides or metal oxides, including what we call the ammonium hydroxide that we are going to discuss, which is a special type of a base. Okay, a special type of a base. So this reaction whereby an acid reacts with a base, it's called a neutralization reaction, and this is because a base is able to neutralize an acid. And what do we mean when we say a base is able to neutralize an acid? Meaning that a base can actually get rid of the acidic properties of an acid, because acids, they always produce the hydrogen positive ions. So what a base will do, it's going to donate either the OH, okay, or it's going to give the hydroxide. So what is happening basically here is that if the acid which contains the hydrogen positive ion reacts with a base which contains either the hydroxide or the oxide ion, when these two react, they'll give out water. Just look at the components. Hydrogen, if hydrogen reacts with either this or this, the result here will be what? Water. Okay, the result will be water. So because of this property, we say that a base can neutralize an acid, because at the end of the day, when you get rid of the hydrogen positive ions, the substance no longer has acidic properties, because what will be there now is water, and hence we say that a base has neutralized an acid, and we call this neutralization. Okay, neutralization. So under the bases, we discussed this even under the reaction of acids and bases. We said that bases are many types, okay, and we said among the bases we have what we call alkalis. Okay, and let's just revise a bit on what we discussed about the alkalis. So if we can recall very well, we said that bases, they are either metal oxides or metal hydroxides. Okay, and we said among the bases there are those which are soluble. Okay, and the ones which are soluble, we call them what? Alkali. Okay, we call it an alkali. When a base is soluble, it's called an alkali. Okay, and those, most of the times you'll find that alkalis are formed between the most alkalis. They will have the hydroxide group. Okay, most of them, they have the hydroxide group, so it's very easy to identify an alkali. Okay, so from this we saw something. We said that all bases, okay, not all bases are alkali, but all alkali are what? Bases. And that's what we said. Okay, so we are saying that all alkalis are bases, but not all bases are what? Are alkalis. Okay, this is something that is beautiful. Okay, so I hope we've gotten something here. Now we are moving on to something different. Okay, we know what bases are, and we know bases can react with what? Acids. Okay, now let's dive into something a bit different. Okay, so let's look at examples of alkalis. Okay, so we have the famous sodium hydroxide, okay, which we call caustic soda. Okay, so we will use sodium hydroxide for many examples. So like I said, you notice there's a hydroxide group in sodium hydroxide. Okay, you also have potassium hydroxide. Also, potassium hydroxide contains what we call the hydroxide group. Okay, you can see it has the OH group. You also have ammonium hydroxide. Okay, ammonium hydroxide. Also, you can see the hydroxide group together with calcium hydroxide. Calcium hydroxide, it is called lime water. Okay, it is important for us to also know the names, the special names. So you see all these contain the hydroxide group. Okay, now we have insoluble bases. Insoluble bases, mostly they are bases such as those that contain the oxide groups most of the times. So you have copper oxide. Okay, you have zinc oxide, iron 3 oxide, iron 3 because actually this comes from the transition elements. Okay, and also lead to hydroxide. So those are the examples of some common bases. Okay, some common bases that we are required to actually know. Okay, we are required to know these bases. Okay, all right, so we move on to something else. Okay, so let's look at ionization of bases. So bases that are soluble. Okay, if a base is soluble, it simply means that this base is able to do what? Soluble means that it can dissolve. Okay, it can dissolve. It can be in aqueous state. Okay, so when a base is in aqueous state, examples I've given these bases: sodium hydroxide, potassium hydroxide, ammonium hydroxide, and calcium hydroxide. All these are in aqueous state. This is because they are soluble and they're able to dissolve in water. Okay, so now when we look at these bases, they can undergo what we call ionization. Okay, ionization is when a base splits into its ions. Okay, so here you have sodium and hydroxide. So this is the split. You are going to get sodium and the hydroxide on its own there. Okay, also when this ionizes, it will split the metal alone and the hydroxide alone. Also here this will split the ammonium ion and the hydroxide ion. The same thing here, this will split your calcium and the hydroxide ion. Okay, so we call this what? Ionization. Remember, even acids also, they underwent what we call ionization. And if you remember very well, if we had let's say sulfuric acid, if sulfuric acid undergoes ionization, also it meant that sulfuric acid, it will give out the H plus the sulfate radical. Okay, the sulfate radical. So this is ionization of acids. So similarly here, you can see that ionization of bases ionization actually alkalis, because alkalis are what? Soluble, and only soluble bases can undergo ionization. So in short, we can say only alkalis can undergo ionization. Now acids were able to give out the H plus ion during ionization, but bases will give out the hydroxide what? Ion. Okay, so that is why we find that when you mix these two, they both undergo ionization, and once they mix, water is given out, and we are going to see this in a few minutes in this same video. Okay, so this is how the ionization of bases actually takes place, similar to what acids do. Okay, so just like we looked at strength of acids, we also discussed strength of alkalis. So the strength of an alkali is simply the measure of its ability to produce the hydroxide what? Ions. Alkalis are classified into weak and strong. So weak alkalis, these partially ionize when dissolved in water, while strong alkalis completely ionize when dissolved in water. And let's look at examples for these. So here are examples of a weak alkali, which we call ammonium hydroxide. So you can see that it is partially ionized, in that when you compare it does not give out actually all of its hydroxide ions, okay, as compared to the strong alkalis such as sodium, potassium, and calcium hydroxides. And here, just to make things a bit easier, so when you notice that the metal, okay, when you see that the metal is a strong metal, okay, the metal is strong, you find that even the base itself will be strong, okay, and that is how these things actually work. Okay, now let's look at we go to properties of acids, bases or alkalis. We see the properties, physical properties, and also we'll see the chemical properties. Okay, so physical properties of alkalis, just like we discussed bases, we said we discussed acids. We said acids had a pH which is less than 7, but alkalis, their pH is usually greater, not usually, but it is all the time greater than 7. When you look at the pH scale, so when you consider the pH scale, you'll find that acids fall under this, okay, their pH is from 0 to 7, while bases, their pH is actually from 7 to 14, okay, so they are greater than 7. They turn red litmus paper blue, okay, so you see a base here, it turns red litmus paper to blue, okay, and they have a bitter taste compared to the acids which had a sour taste, and they feel soapy or slippery between fingers. If you touch sodium hydroxide, you can feel that it's actually slippery, soapy like, okay, and a very, very bitter taste, okay. If you never try to take it in, it has a very, very bitter taste. Okay, so these are the physical properties of an alkali. Now let's dive into the chemical properties quickly. So we're saying chemical properties of bases or alkalis. So number one is that alkalis and bases react with acids to form salt and water only. The reaction that we have called as what? Neutralization. We said this is a neutralization reaction, and in all types of neutralization reaction, no matter how, we discuss this under acids, so I won't go deep into it. So this is a base, sodium hydroxide and hydrochloric acid were reacted. So now what will be formed is a salt. This is a salt and water there, okay, only, okay, under neutralization reaction. So here what is happening here during the reaction, there will be what we call ionization. These two, like I always explained, these will split here, these will split there. Okay, and then what happens is you're going to have separate ions. Okay, let me explain this properly. So find that you're going to have an ion for sodium, an ion for hydroxide, and there once you split an ion for hydrogen and an ion for chloride. These are the things that will be actually reacting after the ionization has taken place. Okay, and once this actually takes place, this sodium here will combine with the chloride there, and that's how sodium chloride is formed. Okay, and then these two will react together, and that is how water is what formed. So the same thing generally just takes place even for copper oxide with sulfuric acid. Okay, we could explain it, but it's the same thing that is basically taking place, okay, under the neutralization reaction. Just to explain it a bit further, question example B. So you're going to have copper and oxide splitting. Similarly, H and the sulfate will split. So copper will combine with the sulfate here, forming copper sulfate. These two will combine, form what? Water. The same thing that basically happens. That's how this reaction actually proceeds. Okay. So another type of chemical reactions that bases have been found to react with the ammonium compounds to form salt, water, and ammonia gas. Okay, that's another chemical reaction. So you find that when you get sodium hydroxide, you react with ammonium chloride. So ammonium compounds are simply all compounds that contain ammonium. Okay, could be ammonium chloride, ammonium nitrate. Okay, they can react with bases, and this will give us three things: salt, water, and ammonia gas. And that these are just examples how this actually takes place. Also, we are saying alkalis react with solutions of soluble salts to form precipitates of insoluble, and we are going to look at this. We also call this another name that we call double decomposition, and we'll look at it when we look at deep into the salts. Okay, you can just break down the equations and see how these reactions will actually be taking place. Okay, and lastly, we're going to discuss uses of bases in our everyday life. So for example, ammonia, we use ammonia in the production of fertilizer. Okay, also used in manufacture of nitric acid, okay, to neutralize acids, also prevent premature coagulation in natural and synthetic latex. Okay, aluminium hydroxide is used in the manufacture of other aluminium compound to make gastric medicine, what we call antacid. So this type of medicine, they're given to people that have got ulcers, okay, and acids. Okay, they work to neutralize the acid in the stomach. Okay, so you find that most medication, they taste bitter because most of them, they have that component of bases. Calcium hydroxide to make cement, lime water, neutralize the acidity of soil, and application of sewage treatment. Sodium hydroxide used to make soap, detergents, and cleaners. Magnesium hydroxide is used in the suspension. When you suspend it in water, it's used as an antacid also. So I find that certain people, when they have acids or they have got gases, they have those stomach pain, they tell them, no, can you take magnesium? Okay, what they're taking is magnesium. The medicine is filled with magnesium hydroxide, so it can work against the acid in the stomach. Also, it is used as an antiperspirant in armpit deodorant, okay, as a non-hazardous alkali to neutralize acidic wastewater. Okay, so these are just some of the uses of bases. Okay, there are many uses. Okay, so I hope you've been able to learn something in this particular video. I hope to see you in our next video as we continue the topic of acids, bases, and salts. If you have any question, please leave it on the comment section as well. Those that would like to join our tuition, we offer online tuitions in almost all the subjects. Okay, you can just reach out to us on this number. You just try to write it here. If you want tuitions, we can help you. Okay, and also please click the subscribe button. If you're watching this for the first time and are not subscribed, there should be a 2 here. Okay, click the subscribe button. If you're not subscribed, invite your friends to follow and subscribe to the channel.